Hello, everyone, and welcome back. Today, we are going to be factoring quadratics in the form of x squared plus bx plus c. In order to do this, we need to find two numbers. Let's let those numbers be s and t, for example, such that s times t is equal to c. So those two numbers multiply to c, and s plus t is equal to b. So the numbers add up to b. Now, keep in mind that this is not necessarily possible for all quadratics. So sometimes you'll be given a quadratic that isn't possible to factor. Either it's not possible to factor with this method because the roots of it are irrational sometimes, or it might just not have any real roots at all. And so sometimes it's not possible to factor, or it's not possible to factor with this kind of method of inspection, which is more or less a guess and check kind of a method. So let's get started with some examples here. The first example is x squared plus 5x plus 6. So for this one, we need to find two numbers that add to 5 and that multiply to 6. Now note that both 5 and 6 are positive, so that means that the numbers we're going to find are both going to be positives as well. The other thing I want to note here really quick is that it's always best and most efficient and effective to figure out what possible values could multiply to the c value first, because there's only so many factors that any given number has. Whereas when it comes to adding up to a certain number, there's just endless possibilities, it seems like. Well, not it seems like, there are endless possibilities. So let's get started with this one. The thing is, for this one, we have 6 is our number we're trying to multiply to. And so 1 times 6 is going to give us 6. 2 times 3 will also give us 6. So which of these number pairings will add up to 5? Well, 1 plus 6 is 7, so that doesn't add to 5. 2 plus 3 does add to 5, though. So 2 and 3 are our numbers because 2 and 3 add to 5 and multiply to 6 simultaneously. And this is what I meant when I was saying how sometimes we won't be able to use this method to factor or won't be able to factor, because let's say that the c value is 6, the only possible b values we could have then would be 5 and 7, and I guess -5 and -7 as well, in order to use this method effectively, right? Without having to think about fractions, decimals, and all those, and irrational numbers, all those kinds of things as well. So this factoring by inspection method is really only effective and efficient in certain cases. Okay, so the answer here is x plus 2 times x plus 3. Okay, let's do another one. Here we need to find two numbers that multiply to 12 and add to -8. Now, because we're trying to add to a negative number and we're trying to multiply to get to a positive number, that means that both numbers must be negative, because only two negatives multiply to make a positive and add to a negative. Okay, so for what negative numbers multiply to positive 12? Well, -1 times -12 does, -2 times -6, and -3 times -4. Now, which of these options can we choose that will add to -8? Well, -2 plus -6 will make -8, and so that's the answer. Oh, by the way, one other thing I should add with this, and really whenever you're factoring anything, let's say you're unsure of your answer, or maybe you're skeptical about whether or not this is actually true, you can always just use the FOIL method or any other expanding method that you know that is valid to expand this, and make sure that when you expand and simplify, that you do indeed get the same as what the question gave. Because factoring isn't a way of changing the actual value of an equation. It's really just about changing the formatting of an equation. So keep that in mind too. We're changing the formatting, but we're not actually changing the meaning of any of these. If you type both of these into Desmos, it would give you the same graph, because these are just two different ways of writing the exact same thing. Okay, let's move on to C. We need two numbers that add to 4 and multiply to -21. Now, in order to add to something that is positive, but have two numbers that multiply to something negative. That means we need a positive and a negative, and the absolute value of the positive number must be greater than the absolute value of the negative number, because again, when we add them, we want the positive to come out on top, right? So what numbers can multiply to negative 21? Well, negative 1 times 21 would work. 2 does not work for 21. Oh, but 3 does. We could do negative 3 times 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. And then we're just back to 7. So these are our only two options in this case that could possibly work. Now, negative 1 plus 21 is 20, so that isn't right. Negative 3 plus 7 is indeed 4, though, so that will work. So therefore, the answer is x minus 3 times x plus 7, like that. Okay, let's try this next one. We need to find two numbers that add to 12 and multiply to 20. And since we're adding to something positive and multiplying to something positive, we need to only consider positive integers here. So we have 1 times 20, 2 times 10, and 4 times 5. Now, 1 plus 20 is 21, so that's not going to work. 2 plus 10 is 12, so that will work. And 4 plus 5 is 9, so that wouldn't work. And actually, I should note, only one of these will ever really work. And so as soon as we figure out that 2 plus 10 is going to work, we can actually just ignore the rest of the list. So there we go. X plus 2 times x plus 10. And there we go. All right, let's try letter E. We need two numbers that multiply to negative 13, that multiply to 40 and add to negative 13. Okay, so in order to do this, in order to get two numbers that multiply to something positive but add to something negative, that means the only way to do that is to consider only negative numbers. So that's what we're going to do. So what negative numbers could multiply to 40? Well, negative 1 times negative 40 could. Negative 2 times negative 20. 3 is a no. Negative 4 times negative 10. That would work. 5 and 8. Negative 5 times negative 8. And 6 is a no. 7 is a no. Okay, so this is all of them then. And the one that is going to work for us is negative 5 and negative 8, right? Because negative 5 plus negative 8 is indeed negative 13. So therefore, we have x minus 5 times x minus 8, and there's our answer. All right, let's do one last one for today. We need to find two numbers that multiply to 25 and add to negative 11. So what we're going to do here is first think about, do these need to be negative, positive, etc. Well, these numbers have to both be negative because they need to multiply together and give us something positive, but it's simultaneously add to something, be able to be added together and give us something negative. So the only way to do that is negative with negative. So the possible answers here are negative 1 times negative 25 and also negative 5 times negative 5. Now, unfortunately, neither of these is actually going to work for us because negative 1 plus negative 25 is negative 26. Negative 5 plus negative 5 is negative 10, which is close to negative 11, but not quite. And so this one is actually not possible with this method, right? Now, there are other methods we could use to, to get a more direct solve, that sort of thing. But in terms of what we learned today, we do not have enough information to solve this. We cannot solve this by inspection. So we can say not possible by inspection. All right. Well, good work today, everyone, and we'll see you for the next one.